welcome to day 4 for Secondary 3 Honors. So up to this point you should have done the first 3 assignments and taken your first quiz on sequences on School City. So if you haven't done that, make sure you do that and stay on top of things. Alright, before we get started today, I just need to tell you how boring it is to teach a lesson to an empty classroom. So to try to lighten things up a bit, I've gone and I downloaded an app with sound effects. So hopefully that'll make this a little more enjoyable for me and maybe slightly more entertaining for you. So to start this off, here's some music to get us started. Alright, here's our lesson for today. We're going to be talking about series. What is a series and how do we use those? Anyway, let's start with just a quick review. So we've been talking about sequences, and the first type of sequence that you learned was an arithmetic sequence. I know this word right here looks like arithmetic, but when we're talking about sequences, we pronounce it arithmetic. It's kind of funny, but it's good for you to know that. What makes an arithmetic sequence arithmetic? The fact that it has a common difference. You're just adding or subtracting the same thing every time. So if I see a sequence that looks like this, I say 3, 7, 11, 15, 19, 23. Let's just say that is my sequence right there. Is that arithmetic? Yes. Well, what is a common difference? You could subtract 23 by 19, 19 by 15, any term by its previous term. And what should we get? If you said 4, then you are correct. Good job. Okay, now what is the explicit formula for an arithmetic sequence? You don't need to memorize these, but it's good if you are familiar with them. The formula is you can get the nth term by taking the first term, adding it with n minus 1 times their common difference. We're going to end up using that as well today. Okay, so that is our first type of sequence, arithmetic. Then we learned about a geometric sequence. I know this word looks like geometric, but when we're talking about sequences, it's called geometric. And that is a lie. You could say I just geometricked you. Oh, these sound effects are amazing. Okay, so now let's look at an example here. Let's say I start with 3, and then I go to 6, and then 12, 24, and then let's just go to 48 and stop there. How am I getting from one term to the next? On this, there is what's called a common ratio. I'm timesing by the same thing each time, which in this case is 2. I could divide 48 by 24, 24 by 12, 12 by 6, and I should always get 2. Now, do you remember what the explicit formula is for a geometric sequence? Anybody? Bueller? Bueller? Alright, so then what it is, I'll just tell you. You're going to take your first term and you times it by your ratio raised to n minus 1. Alright, that should all be reviewed, but it's good for us to remember that before we move on. Now, one thing that you're going to see here that's new is called sigma notation, or it's also called summation notation. In math, when we use the Greek letter sigma, which looks like this, all it means is sum, or in other words, you're adding things up. Okay? Now, underneath it, this is called our lower limit. I'm not sure if you can read that, but it says k equals 1. That's going to be where we start. And what we're going to do is we're going to take that lower limit and plug it into, over here to the right, we have our explicit formula. And we're going to plug in 1, then we're going to plug in 2, and then 3, and then 4, and then 5, until we reach our upper limit. This is where we end. That's the last number we plug in, and then we add all of those together, and that's how you're going to use summation notation. So now, instead of with sequences where we were seeing commas, we're going to see plus signs between the terms because we're just adding them together. So let's do an example here. I'm just going to come down below and we're going to do an example. So let's start out pretty easy here. Let's say we're starting at 1. Most of the time we do start at 1. And let's say our formula was 3k plus 1. And we're just going to start at 1 and go to 5. So what we're going to do to evaluate this series, we are going to plug in 1. When I do, I get 3 times 1, which is 3 plus 1 is 4. Then I'm going to add that with what I get when I plug in 2. So I go to the next whole number. After 1 is 2. 3 times 2 is 6, plus 1 is 7. Then I'm going to go to 3. 3 times 3 is 9. 9 plus 1 is 10. Then we go to 4. 4 times 3 is 12, plus 1 is 13. And notice now we've reached our last term, 5. We're going to plug that in. 5 times 3 is 15, plus 1 is 16. And that is going to be where we stop. No more plugging in. We've reached our limit. Now all we do is we just add that all up. I go and I can either use my brain or I can use my calculator, and I should get 50. Thank you, thank you. All right. Now, how can I check this? You might not know this, but you can do this on your calculator. Let me show you how to do that. By the way, if you haven't downloaded the free software from TI, Texas Instruments, you can do so for free for the next 6 months, and it's usually this is pretty expensive stuff. But anyway, the way that you do that, that you plug this in, is you go to Math, and we're used to going up twice to get to log, but if you go up 3 times, you see right there it says summation. You're going to do that, and it gives you 4 blank spots. This first one says, which variable are you using? I always use x. If you want to choose another letter, you can, but we're used to using x, so I use x. What are we going to start with? Our lower limit is 1. Then we're going to go up. Our upper limit was 5. And then we did 3x. Make sure the letters here match. Was it plus 1? Yes, plus 1. And do we get 50? Yes, I think that deserves another applause. All right. So that's how you use your calculator to check your work. Let's go now, and let's do another example, okay? So let's just scroll down a little bit here. And now I'm going to still start at 1. We usually start at 1. Now I want to do negative 2k minus 1. Throw those negatives in there to make things just a little harder for us. And we're going to go just one further. Let's go to 6. Okay, so I'm going to plug in 1. Negative 2 times 1 is negative 2. Minus 1 is going to be negative 3. Now I go to 2. Negative 2 times 2 is negative 4. Minus 1 is negative 5. And I'm going to keep going here. I go to 3. I get negative 6. Minus 1 is negative 7. And hopefully you can kind of see a pattern. How are we getting from negative 3 to negative 5? This is an arithmetic sequence. We're subtracting 2. Let's just keep going. We can check our work. We're about halfway. When I go to 4, I get negative 8 minus 1. That's negative 9. Then I go to I go to 5. 5 times negative 2 is negative 10 minus 1. That's negative 11. And then we'll get to our last one, which is 6. When I plug in 6, I get negative 12 minus 1, which is negative 13. Okay, so then I'm going to need to get out my calculator to add all these up. I don't want to make a mistake with all the negatives. But if I do negative 3 plus negative 5 plus negative 7 plus negative 9 plus negative 11 plus negative 13. I didn't put the plus in here. I guess it doesn't matter, but just to be consistent. I got negative 48. Now, how do we check that we did that right? Let's go back to our calculator, and let's practice doing this again. So I go to math up, up, up. 3 times math, up, up, up. And we started at 1, and we went to 6 this time, and we did negative 2x minus 1. And we get negative 48. Is that what we got in our notes? It sure is. Let's do a random sound effect here. Cha-ching! Alright, that's a good celebration. Okay. Okay, so that's how you do summation notation for your arithmetic series. Now, if you are specifically working with arithmetic, there's actually some formulas we can use to make life a little easier. Let me try to zoom in here. Now again, you're not going to need to memorize these, but you do need to know how to use them. To be honest, the one that I mainly use is this one. If you guys are planning to take 1050 next year, we do go over sequences and series, so this is good for you to see it now, and this is the main formula that I use, and that most people use. Now let's put this into a real world context. Do a story problem, okay? Zoom out about here. A corner section of a stadium has 8 seats along the front row. Each successive row has 2 more seats. Oh, I need to go out a little bit more. 2 more seats than the row preceding it. If the top row has 24 seats, how many seats are in the entire section? So let's just kind of visualize this. So if you go to our auditorium, you could even see the same thing. Towards the front, there's less seats, and then it goes out to the back. You get more and more and more seats. So in this one, just in one section, it starts out with 8. 8 seats on the front row. And then each row, it adds by 2 seats. So then the second row would have 10. The third row would have 12, all the way until you got to the back row, there's 24 seats. Alright, so then how many total seats are there? Now, avoid the temptation to just get your calculator and put in 8 plus 10 plus 12 plus 14 plus 16 all the way to 24. You'll get the right answer, but what if this had like 100 rows? Then you don't want to use that. This is just good practice for you to get used to using the formulas with some simple numbers rather than just plugging it in your calculator. There will be times you just plug it in your calculator, but let's try using the formula here. So what this tells us right here is that we can actually figure out how many total seats there are using this. Now, do we know how many seats are in the first row? Yeah, there's 8 rows. We're told that the last row, a sub n, is 24. But what don't we know? We don't know how many rows there are. Now again, you could probably figure it out real quick since this is relatively few numbers. But what if there had been 100 rows or more than that? There's a ton of rows. What you need to do is use the explicit formula from the previous page. For arithmetic sequences, the a sub nth term is found using a sub 1 plus n minus 1 times d. What we're going to do is plug in what we know here, and we're going to solve for n. Now the one we do know is d, which is 2. I forgot to put that before, but let's plug those in. So the 24th, that's the last row. First row is 8, and the common difference is 2. What we're going to do is just use some easy algebra here, and we're going to solve for n. So step 1, that's subtracting. 24 minus 8 is 16. What would be the next step? Yes, you're right, divide by 2. Good job, class. So then that gives me 8 is equal to n minus 1. So then last thing here is just add that 1, and we get 9. So n is equal to 9. So there's 9 rows in this section. Now we have solved for that, so we can use our formula for adding up for series and plug everything in. So the formula said the sum of these 9 terms, and usually I just use S for sum. The sum of these 9 rows is, we're going to take n, and then we're almost averaging out here. We take the first, the last, and divide it by 2. So kind of average it out and then just times by how many rows there are. So I'm going to do S sub 9 is equal to, we said there was 9 rows. First row had 8. The last row had 24. And then we're just going to divide that by 2. Okay, so then if we simplify this, this will be 32 divided by 2. That's 16 divided by 2. So if I just do 9 times 16, that's 144, I believe. Let me just check that real quick. question has 144 seats. Now, someone might say, well, how am I supposed to check that? And I'd say, well, you could plug this in your calculator using sigma notation. And they're like, well, we weren't given the explicit formula. Well, you can figure that part out, right? Let's actually just come up here, and I'll show you how I would check this. So, what we were doing right here is what was our explicit formula? Let's think for the arithmetic sequence. Our explicit formula we've written down right here. But let's just plug in what we know here. So our first row we had 8, and then we did n minus 1 times d. And our common difference here was 2. Now we started with n equaling 1, and how many total rows did we get to? There was 9. So now I'm going to plug this into my calculator here, and if you want, you can simplify, distribute the 2 to the n minus 1 and then add that with the 8, but you can also plug it in like this. So let's see if I can get this to work, okay? So I'm going to go to math, up. We're doing x is equal to 1, and then we went to 9, and we said this was 8 plus x minus 1 times 2. Did this right, we get 144, which we get right there. So, awesome! We've got that done. I think that this deserves a celebration. Yes! Let's do that again. Alright, let's go back now. We've got 3 practice problems. First one is sigma notation or summation notation. Now, could you do this by hand and plug in 1, then 2, then 3, all the way to 15? Yes, but that's 15 terms, that's quite a bit. Can you just do this on your calculator? Yes. Let's just do that together real quick here. So, what buttons do you push here? Remember? Math, up. Oh, that didn't work. Didn't recognize me pushing math. Up. Alright, so we're just putting in, I know it says m, but I'm just going to use x equals 1, and then we're going to go all the way to 15. And our explicit formula here is going to be 5n minus 9. Put that in, 465. Awesome. So, if you understand, then using your calculator is just fine because it's going to save you time. If you want to actually write it out and check your work, great. But we get 465, and that's going to knock that problem out. Alright, so 465. Okay, let's go to the next one. This is a relatively small one, so this is just going to be good practice for us. We're not going to use our calculator except to check our work. So, let's go through and figure out, do we have everything we need to know in order to use our series formula? Again, granted, you could just add this up, but get some practice here working with these smaller numbers, getting comfortable with the formulas. So our formula, we have n times a1 plus a sub n over 2. N, how many terms are there? 1, 2, 3, 4, 5, 6. Great. What is my first term? It's 1. What's my last term? It's 16. And then we're going to divide that by 2. Great. Okay, we could do this by hand. First off, 1 plus 16 is 17. 6 divided by 2 is 3. So I'm just going to do 3 times 17, which is 51. And if you wanted to figure out how to put that in your calculator for sigma notation, you got it. But I'm happy with that. So this problem is gone. Alright, now let's go to number 3. Evaluate each arithmetic series described. We start at 13, then we're going up by 10 for 10 terms. So, do we have everything that we need to know in order to use the series formula that we're given at the top of the page? Not quite. What we need to know is, what is the 10th term going to be? Well, if we use the explicit formula that you learned a few lessons back, we know that that is just the first term plus n minus 1 times your common difference. So let's plug that in. To get the 10th term, we would take our first term of 13, and then we do 10 minus 1 times our common difference of 10. 10 minus 1 is 9, and 9 times 10 is 90. So this would be 13 plus 90. So this would be 103. So the last term is 103. Now that we have that, we can go ahead and plug that into our series formula and say the sum of these 10 terms is going to be n, which is 10. We're going to take our first term plus our last term and then divide it by 2. So if we were to go through and do this, 13 plus 103 is, what is that? That's 116, I believe. And then I'm just going to put that in my calculator. I was going to try to do it in my head, but I'm afraid I'd make a mistake. So put it in my calculator, and I get 580. Awesome. So now, this is how you do. Oh, first we need to celebrate that.
Here in my garage, just bought this new Lamborghini here.
Ooh, nice. How about we do one more? That wasn't very good. Ooh, here we go. Awesome. Okay, so now go ahead and start the arithmetic series assignment. And if you have any questions, just let me or Miss Reed know. Hope you enjoyed that. Hope it was a little more entertaining with the sound effects. I'll see you guys next time.